All right, you've had one day to start practicing this trigonometric equations. So let's keep going. And as you can tell, there's not really new notes. I'm just doing new examples for you, okay? So what we encounter here on our second day with A, I see 2 sine squared x minus 3 cosine x equals 0. Equaling 0 is always a great thing, but one thing I'm noticing right now is I've got sines and I've got cosines. And that makes it really difficult to solve. It's better to work all in one trigonometric function, not in a mix. But I notice I have sine squared. So I'm going back to my trusty identity, sine squared x plus cosine squared x equals 1. So if I want just sine squared x, right, I could have 1 minus cosine squared x. So if I do that and do a switch, then at least I'm all in cosine. So I'm going to do 2 times 1 minus cosine squared x, still minus 3 cosine x equals 0. That's cosine, I just can't spell. Okay, distribute my 2 through, I get 2 minus 2 cosine squared x minus 3 cosine x equals 0. I'm going to write in order from highest to lowest power, so I get negative 2 cosine squared x minus 3 cosine x plus 2 equals 0. I notice that I have a cosine squared, I have a cosine, and then a constant. I'm thinking that's probably going to be something to factor. I do not like a negative on my first, so I'm going to just change all the signs. That's like dividing by -1. All right. And again, because my brain processes better this way, I'm going to make y equals cosine x. Okay. And then the first term becomes 2y squared plus 3y minus 2. And I know I can factor that 2y and y. I need to subtract to make 3, so I need a plus 2 minus 1. That gives me plus 4 minus 1. That'll make my plus 3 in the middle. Okay, now I replace that back with my cosine, so I get 2 cosine x minus 1 times cosine x plus 2 equals 0. And now that I have two factors, they're multiplied to make 0, I can make either one of them equal 0. So 2 cosine x minus 1 equals 0. I'm going to just work this one for a little bit. I'm going to add 1 and divide by 2, so cosine x is going to equal 1/2. Take the inverse, and x is going to equal the cosine inverse of 1/2, right? Okay. Where in my unit circle are my cosine values 1/2? That would be true on, this is positive 1/2 cosine, so pi over 3 in the first quadrant. If I add my 2 pi, doesn't matter, it'd be over, so I'm just good with pi over 3. And then I'm also positive in the fourth quadrant, which is 5 pi over 3. Again, if I had 2 pi, I'm over, so I know those two are good. Okay, don't forget I still have this other one over here. Cosine x equals -2. Do yourself a favor and plug that in your calculator, cosine inverse of -2. What you're going to find is your calculator is going to tell you it's undefined, so you don't have to worry about it. So these are my two answers, okay? If you stop back and you think of the unit circle, cosine and sine terms are always somewhere between 0 and 1. Okay, if you think of all those, radical 2 over 2, radical 3 over 2, you have 0, you end at 1. So all your values for sine and cosine are somewhere between 0 and 1, or like not -0 and -1, but in the same respect. So anything between -1 and 1, to be honest, is all your cosine and sine values. If you think of your sine or cosine curves without amplitudes and stuff, everything's between 1 and -1. So if we end up trying to take a cosine or an inverse of any number that's outside of your 1 range, so that -2, it's going to be undefined all the time, okay? So just kind of giving you a heads up on those. All right, so I come over here to number B. That's why I don't teach English. Cosine 2x plus sine x equals 0. Once again, I am seeing sine and cosine. Okay, but the one thing I also notice is my angles are not the same. I have an x and a 2x. So my thought is cosine 2x. I have an identity on my purple sheet that I can look for there. Go to your chapter 5 identity sheet and look up cosine 2x. there's actually 3 different equations or identities you could use, okay? Well, which one is going to be best to work here? If I already have a sine x, it'd be really nice to not have any cosines, okay? And one of them doesn't. So I'm going to choose the one that is 1 minus 2 sine squared x. And then I have my sine x, and I know it equals 0. Okay, so just like on the last problem, I'm going to write these in order from highest to lowest power. So that means my negative 2 sine squared x comes first. That in parentheses really just to show that I plugged it in. It really has no meaning right now. Plus sine x plus 1 equals 0. I don't like a negative on my first term, so I'm just going to change all my signs. Okay. So once again, I'm going to do that little substitution so that I can see this with my brain. So I get 2y squared minus y minus 1. And I'm trying to decide, does that factor? So 2y can only go y and y. 1 can only go 1 and 1. I want a negative 1 in the middle. So negative 1 plus 1 gives me negative 2 plus 1. Yeah, that'll make negative 1 in the middle. Replace the y with sine, so I get 2 sine x plus 1 times sine x minus 1, and I am ready to set these equal to 0. So my left one, 2 sine x plus 1 equals 0, and then sine x minus 1 equals 0. Okay, on the left side, I'm going to skip a little bit of work here, but I'm going to subtract 1 and divide by 2, so I get negative 1/2. So when I take the inverse sine of negative 1/2, I'm asking myself where in my unit circle, because my interval is between 0 and 2 pi, will my values from my unit circle be negative 1/2? All right, negative signs have to be in the third and fourth quadrant, and that's my y value, my 1/2. So I believe those come from my pi over 6's, and that's in the third quadrant going to be 7 pi over 6. I really don't need to add 2 pi because it'll be outside of the circle. In my fourth quadrant, 11 pi out of 6. Don't want to add 2 pi. It'll be past my circle. All right. Over here to the right, I'm going to add 1. So sine x equals 1. So x is going to be the sine inverse of 1, and that's a positive 1. So where in my unit circle is my y 1? So 0, 1, that's up there at 90 degrees, right? Or pi over 2. And that's the only spot. So here are my 3 choices: pi over 7, pi over 6, 11 pi over 6, and pi over 2. All right. Using those identities we've learned earlier this chapter to change things so that we can have common terms and common angles, that was needed because of the 2x and the x. So we really have to watch a lot of those things. And that kind of gives us the hint, like, hey, we need to do something different because I don't even have the same angle. All right. On C, I have sine x cosine x equals negative 1/2. Sine x times cosine x, those two are being multiplied together. All right, so I can think of my identity sheet and say, what can I do with these, okay? I know I have a product to sum. However, that'll leave me a lot of sines and cosines, and chances are fractions because of the adding the angles and dividing by 2. And the thing is, right now, these are actually 2 of the same angle, not different. And the sum to product or product to sum usually have different angles, okay? So just kind of a hint on that one. You know what would be really nice is if I had a 2 in front of this, because then I would do a double angle. And you know what? We can put a 2 in front of it. As long as what I do to one side, I do to the other, it's legal, right? So I'm just going to multiply the whole equation by 2. So on the left side, I have 2 sine x cosine x. And on the other side, 2 times negative 1/2 is negative 1. All right, so I check my formula sheet, again, the identity sheet. 2 sine x cosine x. Notice it's the same angle being multiplied together. That's also known as my double angle for sine. So it's sine 2x. So I can replace all of this with sine 2x. I now have one trigonometric function instead of 2, which means I can work on solving it. I'm back to what I learned earlier on the last set of notes, where I'm going to do a replacement. I'm going to substitute right? Y equals for 2x right now, so I'm going to do sine, don't ask. Sine of y equals -1. I'm going to do the inverse sine of -1. Okay, so I'm asking myself where on my unit circle is the sign -1? Well, that's my y value, so the 0, -1. That's way down at 3 pi over 2, right? It's the only place. Okay, but don't forget, we did a substitution for the angle. Anytime we do a substitution for the angle with sine, we have to add 2 pi n to that, okay? Now we're going to resubstitute, and what's nice is at least I don't have two of them this time, right? Because there's only one place in the unit circle where the sign is -1. So now I'm going to put 2x equals 3 pi over 2 plus 2 pi n. And I need x by itself, so I'm going to divide everything by 2. So x is going to be 3 pi over 4, because divide by 2, divide by 2. 2 pi n divided by 2 is just plus pi n. So I start, if n is 0, okay, then it's just 3 pi over 4. That's definitely in my unit circle. Now let's add a pi, which would be the same as 4 pi over 4, right? So think about that. So 3 pi over 4 times 4 pi over 4, that's 7 pi over 4. That is still in my unit circle. If I add another 4 pi over 4, I'm at 11 4 pi over 4. That is bigger than 2 pi. So I need to stop right here at 7 pi over 4. And I can plug those in and check them, and they both work, okay? And you plug them in and check them in that original sine x, cosine x. So if I did the sine of 3 pi over 4 times the cosine of 3 pi over 4, I'd get -1/2. If I did the sine of 7 pi over 4 times the cosine of 7 pi over 4, I'd get -1/2, okay? All right, last one on this page. Wow, cosine x minus sine x equals -1. Same angle, so that pretty much takes out all my sum to product rules. I'm going to choose a different color. I'm going to get confused. All right, not a common thing, but something to think about as a strategy. I'm going to square both sides. And I can always do that to an equation as long as what I do to both sides. Now, I am going to give you this warning, and hopefully I remember to do it. When you square something, you definitely need to check your answers afterwards, because squaring something can change the signs slightly, and you may end up with an answer that doesn't technically work. So this is one of those times it's a strategy you can definitely square, but just be careful that it might not, your answers that you get might not all work. So make sure we plug and chug them back through. Okay. So remember, if I take cosine x minus sine x and I square it, that's saying I'm taking cosine x minus sine x times cosine x minus sine x, right? Because it says I'm taking it times itself. And by the way, -1 squared is 1. And that is really where we should have warning bells going off that said, I squared -1 and I got +1. If it was just +1, you squared it, you get +1. But that negative being squared tells us there's a chance later we might run into some problems. Okay, FOIL, cosine times cosine, cosine squared x. Outsides are negative sine x, cosine x. Insides are negative sine x, cosine x. And last two is positive sine squared x. Okay, nothing cancels, but I'm going to rewrite it slightly different. I get cosine squared x plus sine squared x minus 2 sine x cosine x. Now, why did I do that? Well, what is cosine squared x plus sine x? That all goes to 1. I need to write that down because it's not multiplying times everything else. It's actually being added to everything else. So I need to subtract it to the other side. I get -2 sine x cosine x equals, when I subtract, I get 0. Okay. All right, now be careful here. We always say get that the trigonometric function by itself, okay? So I could, my nature would be to divide by -2. However, I should hear and think about what I see right here. I actually want to divide by that negative, okay? And just make it divide by -1, but I really want to leave that 2 there, because 2 sine x cosine x, I can rewrite as 2 sine x, or sine 2x, right? Because that's my identity, my double angle, and equals 0. Okay, so I'm going to substitute, right? Because I see the double angle there, it's not just x, right? We're substituting. And I get sine y equals 0. So y is going to be inverse sine of 0. So I'm asking myself, where on my unit circle is my sine equal to 0? And I believe I have 2 spots, right? At 0 and at pi. But don't forget, because I did a substitution for the angle, I have to remember to do my 2 pi n. Okay, now I need to resubstitute. Thankfully, I have a little room over here, so kind of... okay, I'm plugging back in for y, 2x. So I get 2x equals 0 plus 2 pi n. Divide by 2. X is going to be 0 plus pi n. Okay? And then let me do the other one, and then we'll go through at the end and get all of them. Okay, so I had 2x equals pi plus 2 pi n. Divide by 2. And x is going to be pi over 2 plus pi n. Okay, so let's start figuring out what angles we can have. Okay, so 0's first. If I add pi, I'm still within the circle, so I could do pi. If I add another pi, I'm at 2 pi. I don't want to do that. So I'm less than 2 pi. All right, let's go to the second one. I get pi over 2. I add pi to that. I get 3 pi over 2. I try to add another pi to that, and I would have like 5 pi over 2. That's over the circle, so I'm good. Okay. I warned you at the beginning, though, we have to be super, super careful that we actually check our answers, okay? Because of that squaring, this is going to change things up a bit. Okay, I am going to 0 pi, pi over 2, 3 over pi over 2. So it's actually all my axes, right? I'm going to get a fresh sheet of paper to check this because I'm going to run out of space. Okay. So don't forget, our original problem was cosine x minus sine x equals -1. And I just came up with solutions of 0, pi, pi over 2, and 3 pi over 2. But because of that square, I warned you that we have to make sure these are right. So let's plug it in. So I have cosine 0 minus sine 0 equals -1. Well, what's cosine of 0? 1. What's sine of 0? 0. Does that equal -1? No. 0's out. It didn't work. Okay, so let's go next to pi. Cosine of pi minus sine of pi, does it equal -1? Okay, what's the cosine of pi? That's -1. What's the sine of pi? 0. Does that equal -1? Yes. Okay, pi works. That's definitely an answer. Let's check the next one. Cosine of pi over 2 minus sine of pi over 2. Does it equal -1? Well, cosine of pi over 2 is 0. Sine of pi over 2 is 1. But because of that minus in between, does it equal -1? Yes. So pi over 2 works. Okay. Let's check the last one. Cosine of 3 pi over 2 minus sine of 3 pi over 2. All right. Cosine of 3 pi over 2 is 0. Sine of 3 pi over 2 is -1. 0 minus -1, does it equal -1? No. So that one doesn't work. So of my answers, only pi and pi over 2 work. So I'm going to be honest. Technically, should we always check our answers? Yes, the correct answer would be yes, right? But there's very few reasons that it wouldn't work. In this case, because we squared a -1, and we see that when we plugged all those values in, we kept getting 1s. It's just we didn't always get -1, and that was the issue. So, yes, technically I should probably make you go do and plug them in every time. But I'm telling you, these are like the warning signs of when they don't work, okay? So watch that when you square something. All right, back page. It's amazing how long it takes to do one page of notes, isn't it? Okay, calculators out. We definitely need our calculator out, okay? We only have 3 problems left, right? That's not bad. We're going to solve this equation correct to 4 decimal places and anything between 0 and 2 pi. Okay. Every answer we've given so far in this section of notes is in radian form. Because of that, I need you to remember that, and we need to make sure your calculator is in radian mode, because I want everything in radians, okay? And if it's not a nice pi answer, then it's a decimal answer without the degree mark, right? That's a radian. Okay, we're going to solve them. We're going to go to 4 decimal places just because it keeps it more accurate as we need it later. Okay, I'm going to do a side note because we're going to need this, and this is an old note, but we haven't had a need for it lately. Okay, so we've kind of gotten rusty on it and we may not remember this. We have our quadrant, okay? And anytime we get an answer in the first quadrant, it just is the first quadrant. But we also call this my reference angle, okay? So anything in the first quadrant is the reference angle. So if I know my reference angle and I know my answer should come in the second quadrant, I always do pi minus my reference angle, okay? So if you think about it, pi is your 180, you subtract your reference angle, and everything comes off that x-axis. So I subtract it. So when we go into the third quadrant, it's pi plus my reference angle to get in the third quadrant, okay? And then the fourth quadrant, I go off my x-axis. So because this was my x-axis and it's also 2 pi, we don't want to use 0 because it won't get us anywhere. It'll get us negatives. We're going to subtract our reference angle. Okay. So we took that note a long time ago. We haven't had a use for it, but we definitely have a use for it now. One other thing I need to make sure we think of before we do this problem is we're going to radian mode. We know we're going to get decimals, okay? We're used to working in pi. We're used to saying everything to 2 pi. We're good with it. Okay, so think about this. This axis right here is 0, otherwise known as 2 pi. As a decimal, that's about 6.28. Keep that number in mind. So pi over here is about 3.14, okay? So what's pi over 2 at the top? As a decimal, it's about 1.5, I'm too close to the top of the page, 7, okay? What's 3 pi over 2? About 4.71, okay? I say that so when we get an answer, we know where our answer's at. Okay, key thing when we do this, and I can't say this enough, always go for your reference angle, okay? We're always going to go for your reference angle. And as we go through this, you'll kind of figure out what I'm saying, but you always go for your reference angle. Okay. So on E, the first one says tangent x equals 3.1044. So if my tangent is 3.1044, I want to find the angle that goes with it. So naturally, I'm going to do just like I've been doing. I'm going to take tangent inverse of 3.1044. Okay, now before we go any further, tell me what quadrants would you find a positive tangent in? That's all. That's the only, I have this value of 3.1044, but what quadrants are positive? I should get one in quadrant 1, right, because that one's positive. And then I also should get one in quadrant 3, because that's the other place that tangent is positive. Okay, so go ahead on your calculator. Make sure it's in radian mode, okay? So hit that dirge button if you need to. Go to radian mode, okay? And I'm going to just hit inverse tangent of 3.1044. And I get 4 decimal places, because that's what the directions remind me of, 1.2592. Okay. That's the only answer the calculators are going to get me. So if I want to get the third quadrant one, I need to remember I need to take my reference angle and add pi, because that's what happens in the third quadrant. So I have that decimal on there. I'm just going to add pi, and I get about 4.400. If I round, it's going to be 8. So those are the 2 radian angles that will give me a tangent of 3.1044. Okay? I know. This is where it gets more abstract, and you have to just really go back to your basics of how do I find numbers and where do I get them from, okay? Okay, so this next one, sine of x equals negative 0.2315. Okay, I cannot stress enough to you. We are not going to put a negative into our calculator, okay? That negative we're pulling out, okay? So what I always go is we go for the reference angle, okay? So when I do inverse I'm always going to go for 0.2315. I never put the negative in my calculator when I do it. And what I'm going to get first is my reference angle. Yeah, I don't even know if I can spell, but that's okay. Okay, so I'm going to go first for my reference angle. But before I do that, I need to stop and think, where should my two answers come from in my unit circle if my sign is negative? Well, sign is negative in quadrant 3 and quadrant 4. Okay, that's where my two answers can come from. By the way, don't forget quadrant 3 over here. I took 1.2592 and I added pi, just so if somebody looks later and says, where did I get that? Because I was in quadrant 3. Okay, so on my calculator, I'm inverse sine of 0.2315. I'm in radian mode, okay? I get a reference angle of, this is kind of funny when you look at the two numbers together. I get 0.2336. And remember, that would be in my first quadrant. But I want to go over to my third quadrant. So for my third quadrant, I'm just going to take my reference angle, 0.2336. It's not, yeah. And I'm going to add pi to it. So I'm going to add pi. So my first, in the third quadrant, 3.3752, and definitely that's between 3.14 and 4.71. So I landed in that third quadrant, and I know that will give me that negative sign. To get my fourth quadrant value, I need to take 2 pi and subtract that 0.2336. Okay? So 2 pi and subtract 0.2336. And I get 6.0496 if I round to 4 digits, okay? 4 decimal places. So what I really need you to understand is that I am finding radian answers on my unit circle between 0 and 2 pi, but these are decimal answers because they don't come and the values are not from my unit circle. Whenever possible, we use those exact ones, but if not, the values are still there, we just have to get the decimals, okay? All right, one final problem, right? Can't get any worse than where we've been, right? All right, somewhere between 0 and 2 pi, solve for x when we know cosine squared x plus 5 cosine x plus 3 equals 0. Well, what's really nice, we're all in cosine. One's squared, one's not. We've seen today that most of the time when something's squared and something's not, we have to FOIL, or we have to factor, right? It's a quadratic. No coefficient in front of cosine squared x, so all I have to work with is a 3 in the back. Are there any factors of 3 that will add to make 5 in the middle? Sorry, we're out of luck. Factoring is not going to work. But that doesn't mean there's not another way to solve a quadratic, right? Don't forget the trusty quadratic formula. Do you remember it? Negative b plus or minus the square root of b squared minus 4ac all over 2a. And yes, you can use it with trigonometric functions, okay, or equations. All right, quick reminder. When you have this, that your a comes from in front of your squared term. So a in this case is 1. B comes from in front of your middle term, which in this case is positive 5. So important to make sure you have the right sign with that. And my C is my constant, which is also positive in this case, which is 3. Okay, plugging into this, okay? So, negative B, so negative 5 plus or minus the square root of 5 squared minus 4 times A, which is 1, times C, which is 3, all over 2 times A, which is 1. Negative 5 plus or minus the square root. I always take it in pieces. 5 squared is 25 minus 4 times 1 times 3 is 12 all over 2. 25 minus 12 is 13. All right, beautiful, right? Okay, so what does this mean? Okay, we're solving for x, right? Or in this case, we're solving for cosine x. So cosine x equals either negative 5 plus the square root of 13 over 2, or cosine x equals negative 5 minus the square root of 13 all over 2. Okay, that's what that means, that I solved, quote, for x, but this time it's cosine x because it's all there. All right, to be honest, I just need a decimal for these. So -5 plus the square root of 13. Make sure you close that parenthesis. Divide by 2. And in this case over here, cosine x, 4 decimal places, guys, 4 decimal places, -0.6972. Okay. On the other side, cosine x, and now we're going to go -5 minus the square root of 13 divided by 2, and I get -4.3028. Okay. Time to solve, so I'm going to do x equals cosine inverse of this -0.6972. It's calculator work. I make sure I'm in radian mode. Inverse cosine. Remember, we don't plug in the negative, right? We only plug in 0.6972. We're going for our reference angle, okay? So my reference angle here is 0.7993. Okay, where are cosines negative? So I need a cosine negative in quadrant 2, and I need a cosine negative in quadrant 3. So to find my quadrant 2 value, I'm going to take pi minus 0.7993. And don't forget, for quadrant 2, I'm going to do pi plus 0.7993. All right. I'm going to add it first because it's just easier. It's in my calculator, 3.9409. Pi minus is 2.3423. And I still have this other side to do. Inverse cosine of -4.3 ... right? Can I take an inverse of a cosine that is outside the 1 range? No. So this can't be done, right? So that one is just done. We don't have to worry about that side, right? And so my two answers are 3.9409 and 2.3423, one from the second quadrant and one from the third quadrant. All right. We kind of just added a whole new layer on with these back 3 problems, okay? They're possibilities. We got to keep that in mind, okay? So you don't always get values from the unit circle, and if you don't, it doesn't mean that you can't solve it. It means that you're going to decimals in radians instead of values we're used to in radians, okay? Can I stress again? You got to practice. That's the only way these start clicking, okay? So homework, page 636. Number 63 through 114, because you already did the earlier ones, right, by 3s, and then you're bringing questions to me, right? We're going to go over these. I know we can't be together every day to go over them, but you need to practice so we can get ready for that test. Let me know if you have questions.